Hi, my name is Anika, and today I'll be talking about microevolution. Microevolution is happening all around us, and understanding it helps explain things like antibiotic resistance, changes in species behavior, and even human evolution. So let's dive in. Microevolution refers to changes in allele frequencies in a population over a relatively short period of time. This is different from macroevolution, which involves the formation of entirely new species over much longer periods. One classic example is the peppered moth during the Industrial Revolution in England. Originally, most moths were light-colored, blending in with tree bark, but as factories released soot that darkened the trees, darker-colored moths became more common because they were harder for predators to spot. This change in allele frequencies is microevolution in action. There are a few key processes that drive microevolution, and these include mutation, gene flow, genetic drift, and natural selection. Mutation involves random changes in DNA that can introduce new traits. Gene flow involves when individuals move between populations and they bring new alleles with them. Genetic drift refers to random events like a natural disaster that can drastically change allele frequencies in small populations. Natural selection includes traits that improve survival or reproduction that become more common. A great example of natural selection is antibiotic resistance. Antibiotic resistance is a perfect example of microevolution that impacts our lives today. When bacteria are exposed to antibiotics, most of them end up dying. But some have mutations that allow them to survive. These resistant bacteria then reproduce, passing on their advantageous traits to the next generation. Over time, an entire population of bacteria can become resistant, making it much harder to treat infections. This isn't just a theoretical problem, it's a global health crisis. The World Health Organization has called antibiotic resistance one of the biggest threats to human health today. Understanding the microevolutionary process behind it can help us develop better strategies to slow its spread, such as using antibiotics responsibly and investing in alternative treatments. You might think microevolution isn't important, but it's happening around you all the time. For example, the flu virus evolves every year, which is why you need a new flu shot annually. Pesticide resistance in crop pests affects the food we eat and how it's grown. Even traits in humans, like lactose intolerance, have evolved through microevolutionary processes to adapt to our changing diets. Microevolution helps us understand how species, including us, adapt to our environment. It's a reminder of the dynamic, ever-changing nature of life. So the next time you hear about antibiotic resistance, flu vaccines, or even changes in wildlife, remember, microevolution is at work. These small genetic changes may seem minor, but they can have a huge impact over time. By studying microevolution, we gain a better understanding of the natural world and our place in it. Thank you for watching.